we are going to do one more lecture before the next exam. So that way you have a little more time to assimilate the material from this exam. I will make sure that the exam practice goes up hopefully Thursday, hopefully. But I will make sure it's up by this weekend. So that should take care of that there. Let's go ahead and share for you. And we left off with questions. And let's see what we get when we go to catalysis. So, catalysis. A catalyst is a substance that increases the rate of the reaction by lowering the activation energy. Oh, that's how it does that. So yes, it lowers the activation energy. Now, it does not affect the position of the equilibrium. It doesn't affect how much product I have, how much reactive I have. It doesn't change the value of K, the equilibrium constant. It could be heterogeneous, meaning it's in a different phase, or it could be homogeneous, meaning it's in the same phase as our reactants. And enzymes are a form of catalyst. Now, enzymes typically work by improving the probability that our reaction is going to have the right orientation, because it'll hold those two pieces in the right place to get that reaction to be successful. Okay? So if we look at our diagrams down here, we have this initial reaction, which has a fairly big EA. We have this next one where EA is a lot smaller. So this is the one that's using a catalyst, and this one is uncatalyzed. Which is really weird, and I don't even know if it's a real word. Okay, so that's the kind of thing that I'm looking at between those two diagrams, right? Notice that the overall energies have not changed, just that activation energy. That's the only thing. Let's see that again. No, really, I mean it. So another view. So here, again, we're looking at starting with this H2C double bond C, H2 plus H2. That then gives me H3C, CH3. I know that this gives off energy, so it's exothermic. This transition state right here is a lot lower than the one right here. So this higher peak is the activation energy of an uncatalyzed, oh, that is a word, awesome, reaction. And this one, this lower one, is the activation energy of a catalyzed reaction. So this is another way you might see something like that. I might ask you, label things here. So this is my transition state. This one is catalyzed. So label it like this. So this one's catalyzed, that one's not, that kind of thing. So you might be asked to label any and all of these things. We're not expecting you to know what the reaction or products are. Oh, I'm sorry. I apologize. I swear to God, every time I get on camera, that happens. So that's another thing that you might see in terms of catalysis. Oh, here's another practice. So, is this reaction catalyzed? Yes, the blue line has a lower activation energy, so that is a catalysis reaction. And what does the bump on the blue curve mean? Oh, this bump right here means that there's an intermediate, which means that this catalyzed reaction has 2 steps. Okay. And there are 2 activation energies associated with it. So what would I call the species that exists after the first peak in the blue curve? That's an intermediate. Does the catalyst affect the overall energy of the reaction, starting and finishing, the net change? So from here to here, does that change? And the answer is no, it doesn't. What happens to the catalyst after the reaction? That's fun. We haven't talked about that, but we did talk about that. And let me remind you where we talked about it. Gotta flip back. Come on. I got too far. Out there. Come on. One more. Ah, here. So we put it in, we got it back. That's what happens. And I said it might be a catalyst. And that's because it's not consumed during the reaction. It is not consumed. We use it to do something, and then we get it immediately back. Okay. Oh, it may not be immediate. So, nothing. Nothing happens to it. We get it back, and it's like nothing happened. Okay. So as far as that is concerned, nothing did happen. Awesome. Questions, comments, problems? I hope not. We'll give you a few more sample questions and then we'll be done with catalysis. Can I predict from the balanced chemical equation what the rate law will be? No. Can I predict the mechanism from the overall balanced equation? No, I cannot. Determine a rate determining step. Define it. Okay. It's the slow step. That's what we're talking about. It's the thing that determines the overall reaction because it's the slowest thing that happens. Real life example of something that mimics a rate determining step. My example was that turn from palmetto commerce onto athlete phosphate. But anything you can think of that is slow in a thing that has multiple steps, that will work. In this diagram, tell me the definition of all the terms and symbols. So R, reactant, P is for product, EA is an activation, and the intermediate is a species it's made, and then step. And it's just a step process. Cool, awesome. In industrial chemistry, there are often multiple ways to make something. Would those different ways have any of the following in common? So multiple different ways. Energy intermediate? Maybe, maybe not. Activation energy? Maybe, maybe not. Energy of the products should be the same no matter how I do it. Number of steps? Probably not the same, but it could be. And my rate determining step? Not necessarily. So the only thing that's really going to be consistent between these, if I graph this, would be that gap right there. So the distance between my reactants and my products in the overall scale. That's the only thing that's going to be consistent. So the height of the peak could change. That means the activation energy could change. The number of steps in between those two could be any number of things. And of course, different processes, different mechanisms will have different rate determining steps. Okay, so those are your sample questions. Questions, comments, problems? Well, again, I hope not. This wraps us up with all of the material for exam 2. I will get that review sheet up for you as soon as I can. I'm going to go ahead and close out of this. Stop sharing. And stop recording so that you can watch this video. Thanks, guys. See you soon.